super excited to host Theodore Galanos. I, this is the fourth time I'm interviewing him on my podcast, and it's always fun, insightful discussions about AI and technology. And Theodore has been an amazing voice in the space, sharing interesting, thought-provocative ideas. So thanks a lot for being on the show and your time for this.
Thank you for having me again. Yeah, it's really nice to be here.
Yeah. So from the last time we discussed, there has been a lot of things you have done till date. So if you want to share what are some recent experiments you are up to?
Sure. There is as always multiple directions in how I'm personally at least advancing my thoughts on the field. The vision and the goal is to eventually get to something that we can call intelligent design. And one of the things that has happened recently, especially with my move back to industry, is that and with Oricon is that I have had to think about design in a much broader term, a much broader sense. So before, I was mostly interested with the generative part, which is good because this is the topic of our talk. But then, if as I typically show, if people have seen any of my presentations, generation is just one of the steps. You need a lot more steps, right? And it turns out that is also generation can also happen in many other areas than design itself, design artifacts. So one of the things that has happened is that the scope has expanded a lot to include, a lot of upstream and downstream things, and a lot of things that might not seem directly design. So, for example, language. There is a lot of, information exchange, documentations, and a lot of things that are in and around design that are valuable sources for this kind of applications, and we have been using them so much. So that's one of the focus that has happened lately. So like language, but a bit further away from design, and a bit closer away to the design process, and even like to the whole implementation of a project, right? And another thing that the other thing that things that happen is a bit with architects. Like we have had some cool like research going on with architects, especially with a community called Carper. This is just an open source project. Anyone can join in Carper AI, and you can even join and play around with architects. And the goal there is to do a bit of partly reinforcement learning, so partly like fine tuning models based on some sort of reward signals that we care about, and partly learning from human feedback, which I think is probably the most exciting area of AI right now, at least the one I am keeping tabs on. And it's quite easy to justify because everyone is turning to that right now if you just notice around you. And that's another area also where practically I've been working on. So like, how do we codify, collect, curate, and use expert knowledge that we share daily? And I think that's going to be a huge step for the AEC industry. And the interesting part, and I showed this into some presentations lately, is that the AI companies are already doing this. So like there was this OpenAI job application. I can send the link here later if I find it. It's archived now. It's gone. So they were asking for, I think, engineers, physicists, sociologists, I think it was philosophers, anything but AI researchers. And essentially, they wanted them to annotate their models, right? So they were asking for expert knowledge. Why? Because they don't have it. But we do have it. We share it every day in our work, we discuss it every day. We just never collect it properly. So one part of my work currently, an exciting part, is this, like understanding how to collect it and how to use it to create new types of models. Yeah.
Got it. And when you say you're like, are you developing a pipeline of codifying architecture knowledge non-visually, like in non-visual format? Yeah.
Yeah, so it's more than architectural knowledge. So this is design engineering, of course, because that's sort of my practical work. And again, at my place of work, Oricon has a wide range of things they do like really really wide. So it's everything, but it's also more than visual. Like you said, it's different types of knowledge. Typically we communicate with language, so we started with language, but there are also many other modes of communication. So there is multimodal, eventually will be multimodal representation, but we started with language in a way, just because there is so much data there. And yeah, it is a pipeline, but a lot of the parts of this pipeline are sort of like soft implemented, like in the sense they have to do with people and not really with technology. So that's the interesting part, and they have to do like with things like trying to explain to people like why is this useful, right? How can they put it inside their busy days or busy, how can they make it a practice, a routine, right? And the surprising part was that this wasn't hard to explain, because again, my intuition was that these people are already doing this, right? They're already sharing knowledge. They already have templates they use to share knowledge, right? Everyone, we all use templates everywhere, right? Have a template for emails you send. I don't know. You have a template for projects, for reports. So it turns out that they've already been doing it, and just by showing them what others have been able to do with these methods, it gets them intrigued in a way. So yeah, that's sort of the pipeline now, and this connects to design eventually. Like, first of all, you can also do this on design, so you can collect human feedback while designing. That's one of the interesting research outcomes, hopefully, of the Carper AI architects. So we have a UI that we haven't deployed yet, but might be deployed next week, where you can give your feedback and critique, evaluations, all these things. But also, like, it captures a lot of things around design that are useful and typically are not connected to the generative model, let's say, right? They're non-visual. Yeah.
Okay, and for the humans in the loop part, if I'm getting it right, you're using that data for the training in the down. So it's like you get more like validation, okay, for improving your models.
Yeah, yeah, we're using exactly the human in the loop process. I think a year and a half ago, I think I was describing that sort of. I have a map with various dots, that is stepping stones to intelligent design. I think I was calling this designer modeling in a way. So you can think of it as personas. If you go towards generative design, it would be like kind of fine tuning models in specific design
Yep.
personas, but all together in a way, and not just, oh, this is because we see a lot of stable diffusion models now, it's on Arcane, on, I don't know, Anim, or, those are like more task fine-tuned models, right? They've taken a model which is general, they've shown it a bunch of arcane pictures, right? And it can do this task, right? So the idea is to do this for architecture, design, engineering, advisor, and anything really on a multitask fashion. So like to have like multiple personas within the same model, and to prompt these models accordingly as you want, right? So that's the idea, and yeah, it's a human in the loop thing, and like I said, I think is the most active, one of the most active areas of research right now in AI. Yeah.
So for like AEC firm to integrate ML in their workflow, what's a guideline you would recommend? Because from what I foresee is there are large language models which are open sourced. So first task is fine tuning for their particular specific task in the firm. But before fine tuning, they should have data which is compatible in the fine tuning training aspect. So what are the foundations they should prepare in order to do this?
Yeah, I mean, data is the foundation for sure, right? But even before that, you need a couple of things. First, you need a sort of culture of innovation. That's very important, right? uh, that allows you to focus on the new things that are exciting and experimenting, right? Instead of, like, I don't know, fighting about, manual versus automated labors or things like that, distractions. So if you have a culture of innovation, you can pierce through that and just say, okay, these are a bunch of experiments that look very nice, very interesting. Let's do them, right? So that's the first. The second, yeah, you need data, and even more importantly, like, you need processes that, generate, either generate or collect curated data. So like collecting a big data set is very helpful, right? It will help you like actually do the task. But if it's a one-off, it's you might as well not do the effort, right? So it's even more important to have this, like I said, routines, processes in place that somehow feel natural and allow you to collect this data in the future. Like they keep doing this for you, right? So even if these companies don't have enough data to train their own models, and we probably don't, it's still worth starting the process, right? Okay, maybe if someone goes, if you propose a project and tell you, yeah, this is very difficult, we don't have the data, how we do it, then you can say, okay, sure, let's start collecting it, and I come back a year later. So that's very important, right? The data, you need it to start. And the third part, I think, is like we are not really expected, I think, to be AI companies, and we shouldn't be AI companies, right? Even though I do think that slowly we should have like, AI departments and things like that, and a lot of companies do have, for example, big, mostly big, like multidisciplinary companies that do have data analytics, machine learning, AI. And we're not expected to be AI companies, right? And I think so. I think the most important part, and this is more on the business side, which is just my opinion, is that given the progress and the rate of progress in AI, the best thing that we can do just right now is just keep with that pace in a way. Like even if you're not implementing everything that's going on, at least understanding what the capabilities are, what the big leaps were, have an intuition of connecting the new thing with the tasks that you want to do. And if you can do that, and then just also do a handful of experiments, you are in a position, and that's the most important part, to reach out for sort of cross-industry collaborations, which are the most important. Like, because again, we are not expected to become AI companies. We'll never be, as good in, deployment in large clusters and all these things as the AI counterparts are. But also the AI counterparts, as this job ad from OpenAI shows, will never be engineers or physicists or, architects or designers of any kind. So that cross-industry collaboration is huge, right? It has to happen. And in order to happen, I think you need to have first this understanding, so that when you sit down on the table, right, you're not just the person that brings the data or like some sort of expertise that is going to be used and thrown away after, but also like for the other parties to know that, okay, they understand what you're doing. We can see that they've done something similar. So like we can talk with the same terms. We don't need to translate or all these things, right? So I think those are the three parts. And then a lot of experimentation. A lot of experimentation. When implementing, I guess, if you try to change, I think within a cultural company, like again, the other practical part is to go for like small wins in a way, like find a problem that is important, that machine learning or AI can solve, maybe even, I know that, the first thing should be without machine learning AI, but if you see an opportunity, try to solve that small problem, make a demo. And the AI domain has made it very easy to do this just now. There's a lot of, 2-minute deployment of models, right? There's thousands of models off the shelf you can use, right? So experimentation is easy. Deployment is harder. Like actually deployment in production, that requires a lot more. So I would, either you develop your expertise, which again, I don't imagine every company will do, or there at that point, it's not bad. Like even if you implemented your own model doing a task, it's not a bad idea to say, okay, now that I want to productivize it, maybe there is the API out there that I can use, right? Maybe I can collaborate with them. They can do my deployment, my fine tuning, everything, and find some. So that's not necessarily a bad thing. It's not a bad thing to, as long as you know what you're doing, and that external dependency is not going to destroy everything, right? And the last part, like that I find interesting, is that typically if you are a DevOps person, when ML comes into the scene, it's a nightmare. Like it's really hard to sort of start deploying or implementing it in a corporate level or company scale, right? But with language models especially, that's why I'm so fascinated by them, it's much easier. I think it's not like the interface that you have between the models and what they're doing is now language mostly, right? And you can see that even with code models, so I think that's why I say to keep with the developments. I think if you understand that this interface towards different things is shifting from some complicated structures, I don't know, to just language and communication between the people and models, then you will be ready for the proper shifts that might happen. Yeah. So those are the things that, yeah, some big points about.
Yeah, that's awesome. And uh, you covered like where the high level approach of up- uh, adopting this. If I were to ask, give me one low-hanging specific task which a small and medium business should do and a large firm should do just to validate.
So yeah, I wonder if I've never thought about this properly, if the task changes if you're a small or a large company, because it probably relates to how much data you have in your disposal and funds, I guess. Although small companies can be much more lenient and flexible, right? And they can do even larger products. I think, yeah, like I said, I think that the easiest thing to do is like find some open source model out there, and there are a lot that relates to your activities, and just try to fine tune it to fine tune it to your specific task, right? That's the easiest thing to do. Even easier than that, perhaps, is to get the off-the-shelf models that already do tasks that are useful and try to implement it into your processes, right? Try to embed it into your. So, for example, you can think of like, how to do search better, right? How to retrieve, you know, designs or documents or images or whatever, things like that. How to answer questions, right? How to help users, that might be the easiest, like how to help users find knowledge and information. That's kind of something you can do with these pre-trained models pretty well. Like I think it takes maybe like 5 minutes of time or 10 minutes for me, who I'm not a developer, to create like a demo search engine, right? It's not very difficult, right? With, go to Hugging Face, download the model, give it some documents and search, right? So these kind of applications are nice. If you're going towards design more like, I think, it becomes a bit harder. Then you need to create the, specific data that you want. But yeah, on the generative side, I would say, yeah, perhaps the semantic generation aspect is interesting. So that as a smaller firm, perhaps, I guess, or like startup, maybe that's what people would be looking at. Like, how can generative AI help? And there was a very nice report by Sequoia, I think, a couple of weeks ago, for a VC report. It was really nicely written. And they talked about these sort of waves and how we are in the wave of killer applications, right? Like, stable diffusion, the mid journey and stuff like that. So a, a, a low hanging fruit could be like, can you create your own killer application, right? And that would be an interesting thing. Like, and it sounds like it's not very low hanging fruit, but it is, because the model is there. There's thousands of people fine tuning it, with different ways, sharing their collabs, like the model. One of the big revolutions of that model, why I like it so much, is that you can run it on your laptop, right? You can even fine tune it on a, I don't know, 20-cent GPU probably per hour. So that's probably the very low hanging fruit. One issue is that it, and that's my personal issue actually. It's not really. I think other people more creative than me will solve it very quickly. Is that these generative AI models, they don't do like yet structure outputs, which is what I would like to have. Uh, Especially if you move towards engineering, a bit less like concept design, you do need like structure outputs. You need geometry, right? You need meshes or models or lines or curves, polygons. You need something that you can use downstream, right? Uh, so I think that intersection between, like, there is some generative models there, either vision or language, and there is a task that I have that I know very well. This is what I do every day. That's the biggest low hanging fruit. It's not because it's easy to do. It might be very difficult. Like, how do I make 3D models with diffusion, right? Maybe this is no one knows, right? Or it takes like 2 hours, 30 minutes for a model right now. How can you make it? But still, is a task that you can offer a lot. That's what I meant about cross industry collaboration. because you have the expertise on 3D modeling, for example. You have a dataset of synthetic 3D models, right? You have a pipeline where you can deploy these models. So all you need is a collaborator that knows how to do the AI part, right? So I think that's what I would suggest. Like the problem you know the best, and you can generate data because we don't have enough, and then just try to fight with that, right? For larger firms, I think it's easier in the sense that they have many more problems in a way, many more tasks, many more solutions to be found. And like I said, with scale, there's more expert knowledge. There is more like expertise that you can attach to. And because of the volume of data, they also have like other modalities that are interesting. Like I know it sounds a bit weird to say that language documentation is very important for design or engineering, but it is because a big part of projects is there's a lot of documentation, and that documentation refers to aspects of the design, right? So if you can extract knowledge from there and even use that knowledge to answer queries, to generate new responses or even new designs, that's pretty impactful. Yeah. So yeah, I think that.
That's a great answer. And one thing I would also like the people who are watching or listening this is, as Theodore's mentioned, you could leverage existing trained models and test it with the data set you have. And if you use Google Colab, you could even like train it for free. So the
Yeah.
cost to do the first ML prototype in your firm could be less than $100 to validate, because so
Yeah.
it's not like a one if part like a lot of articles say it's very expensive to train models, and hence you should not pursue that part. I think the fine tuning approach, or like developing on
Yeah.
trained model, is very low hanging way of you validating whether it's helping in some task. And there are a few construction companies who are testing out with like generative scheduling or using time series
Wow.
data. That's pretty interesting. And we have seen a rise of like text to image a lot in the past 6 months. And there are startups or companies who are being uh, developed right now who are doing text to 3D, which is gonna affect
Yeah.
our space. Or like a new AI based 3D modeling engine, where instead of you doing sequential approach in the normal way, like there could be other where you just hover over the object and then you can type the texture prompt, and then suddenly all your so we are the ones who could think about, okay, what's the new way of design AI augmentation, and what's the interface, because that's our knowledge expertise in the composition of APIs from various OpenAI model, and also developing a UI UX in a way which helps the modeler or designers.
Yeah.
So
Yeah. Absolutely. Like that's what I mean by we have as much to offer, right, as they have to offer us. Simply because we are the ones, or the industry is the one that knows what they need and how to use it. And even the interface you said, I think that's the most. I think that's the biggest part of my sort of intelligent design landscape, and it's hard to explain to people like that. Eventually, when the other parts get to the point where they can be, like when we have generators that are incredibly diverse across many tasks, where we have like proper design exploration again across many tasks, and even like built in like designer personas and human feedback. Eventually, like the last part we're gonna have to think about is interfaces, and this is partly UI UX, but it's also like a completely new interface. Like, so like the same way like as language models are changing the way you interface with things, right? It's almost like I like there was this paper by uh, I think it's Sergey Levin and group, and they were talking about learning new interfaces, right? Where no interface exists. So imagine, for example, like you open a canvas, there is nothing there, right? And I use this example when I describe intelligent design. What does it look like? and my example, okay, my example, I will say the first one and then the adaptive one now. The first example is like imagine grasshopper or whatever, like you create some logic to do a parametric model, right? It's really good. It takes you, you're very experienced, and maybe it takes you like 4 hours, 5 hours. You sit down, you do it, you've done it before, maybe you copy paste some knowledge there, which is very hard, but anyways, different matter, and you do it. And now you can create a wide variety of office layouts or something like that, right? And then you leave it there for a few weeks, and then someone asks, like I want to assess, for example, like, I don't know, connectivity within office layers. Then you think, okay, I have one, but it doesn't have any doors. I only made it for volumes, right? Here you go. You can add the logic for doors and you calculate. How long do you think that takes, right? This, even if you are very experienced, I think it could take like hours, right? For the other person to say, okay, what have they done here? How can I implement it? How can I put doors here to connect and calculate? And yet, if you take one example of this design, right, and you give it to any human, just find one in a coffee shop, you give them a design with no doors, and you tell them, can you add some doors in here? They will do it, zero shot. They don't need to think about it. They might not do it perfectly, in the sense like the doors might be a bit weird. They're not architects. They can't quantify connectivity on paper, but they will do it zero shot. They don't need anything, right? To any training. They don't need this 3 hours of embedding a logic of adding a simple door, right? So that's intelligent design. Intelligent design is something that will do all these things zero shot, right? You won't do all these tasks in zero shot, generalize across tasks, and importantly, and this is the craziest part, generalize across tasks that we don't even know exist, right? So that's the point of intelligent design. And it has to be in this way, like, and that entails like learning new interfaces, right? That doesn't, it means in fact that design won't even happen in the places that happens today. It will happen in an empty canvas where I draw a polygon, and maybe the software starts to think, okay, what are they trying to do? Is this a layout, or is this like a box, right? Or then you draw more details, and the interface, it's learned on the spot, right? And there was this nice paper, and they started, I liked it because they started describing how would you talk with aliens, with an alien civilization? You wouldn't. There's no interface of communication, right? You would try to understand. That's exactly how I think our initial contact, or maybe our daily contact with intelligent design will be, or has to be, a sort of alien interaction in the beginning, but very quickly adapting to the specific task that we want to do, right? So I really like the interface thing you mentioned. Is the hardest part, probably the last part, but it might be an important part, because it will be very, I think it will be very weird to most people, like, yeah, to work in that environment, right? Imagine an environment that, yeah, you don't even have, imagine, for example, like you take that polygon and you cut the line, right, some way, and you add something, another element, and then you say this is the element. So, and immediately the interface understands, okay, this is a task that they want to have. So here's a button, and when you press it, the object you have will be cut, and this will be added. So all this, yeah, that's how I imagine intelligence.
Yeah, like
Sorry, that
kind
was
of
a offshoot. Yeah, sorry.
adaptive ML interface, which is like has cognitive, maybe on like more how we have like autocorrect or like
Yeah,
speech recommendation, where here, because design space is so complex and there are
yeah,
so like multiple parties, and to your earlier point of participatory design, so in this blank infinite canvas, like maybe whatever stage I am, the interface gets changed based on what
yeah,
I'm interested in, what I'm like. That's what I like initially about the sketch RNN models, where sequentially I know what I would like to draw next.
yeah,
So I don't know how
yeah,
to do it in
exactly.
multimodal.
The infinite canvas is a good way to describe it. And yeah, it's this idea, like generalization is how they call it in ML usually. Plasticity is how I would call it outside. Like these interfaces, they have to be absolutely plastic, right? They have to be just adapting. And this is what we do. Like it's not so. There has to be an aspect of reasoning. Like why are they doing? What are they doing? Communication. Like all this. And there's been like work on that, right? The paper that I reference, for example, they learn an interface I think it was, you know, this game where you try to, the lunar lander is a very
Yeah,
popular RL thing, right? Where you can actually with the joystick try to land the thing. So they started, and every movement in the joystick was random. Like you would press down, it would go like up to the left. You would press right, it would do acceleration, whatever. And then, so the software had no interface of flying. And then slowly, with the process of learning, right, mutual information. So the user pressed left, they went up. Oh, maybe I pressed down. So slowly from this interaction, they learn the actual interface of flying. So this is how I imagine it will have to happen, right? Because if that doesn't happen, it doesn't scale. Uh, because, like you said, it's infinite complex design, right? We have arbitrary tasks. Like, what are you going to do? You're going to build a UI for each one of them, right? No, you build UI for all of them. No, that doesn't work. Also, so it needs to be flexible like that. Yeah.
yeah. And I was listening to like one podcast where they were discussing where is the moat, like the open, like uh, does the infrastructure companies providing this large language models will like is the core or will make more money, or the startups who
Yeah.
add logic or business logic on top of it will survive long term. So what are your thoughts on that?
Yeah, that's tricky. Like for now, obviously, like it's not ideal, I guess, because there are a lot of startups, and some of them might become valuable very fast that are building off of essentially other APIs, right? And it's really difficult because they are absolutely dependent on that. So there was this discussion. I think I was listening yesterday from ML Street Talk, like with Hayden Gomez, like the Cohere CEO, and they were talking about that, like you know, you know, these APIs they can blanket cut access. They can change the terms. Like it's normal, right? It's their product. Imagine they it's their terms, right? So it's not ideal. Like I said, there are ways out of it. There are open source models that are being developed and they're very good. uh, Not just about from open source companies, but even like large companies. Like we saw like the Flan T5 models, even Galactica a couple of days ago, and people are fighting about it. And like a lot of like language models, Stable Diffusion is free, you can download it. So there is a lot of open source thing that you can use. Like you say, build your demo, get your funding if you're a startup, and then somehow find a way to do it. But still, I think if you want to scale, yeah, you can't really like this APIs. They are companies with hundreds of millions of dollars of funding and the best people in the world, right? In ML deployment, training, finding. So you can never really compete. Your system is not going to be faster than them, right? It's not going to be. So eventually you will collaborate. But at the moment, I think that it's very new. It's a new field where only a handful of APIs exist, and I think the power is a bit asymmetric, right? It's on their side. Like it's much easier. It's not like oh, I'm renting some instance on the cloud, and if they cut access to it, I can just migrate it to another cloud. Even there is, of course, the power is kind of the cloud provider, but it's so popularized, and it's everywhere. So it's not like you will lose access to a cloud in a way, right? It's highly unlikely, but with the APIs you do. So it's hard. So yeah, I'm not sure. I think it's a tricky thing, but you can't really do a big scale deployment like without this APIs. So it's kind of tricky. Yeah, I imagine that these marketplaces, they will mature slowly. So there will be more competition. More places coming up, and also they will mature in the business practices. Like for example, I can only speak about OpenAI. Like I know a few people there, but I don't know the policy of the company, not at all, right? But it doesn't feel like they're product oriented in a way. They just have an API and then they're like, okay, sure, use it if you want, right? That's cool for users, but it's not useful for companies or startups, right? They want like more support. They want someone there to help them. Maybe can I have this in my cloud? Can I have locally? I cannot share the data, all the stuff. Other now APIs are coming out and helping a bit more with that, right? They are a bit more handholding for people that cannot do. And we can see already a few. So that's interesting in language modeling, at least. And yeah, but yeah, it's tricky. It's tricky. I don't know how. Eventually, there will be like larger startups that will create their own infra. When you get to that point, you get your own infra, your own models, you hire your own people. But yeah, the beginning is it's sort of a leap of faith in a way towards these API companies.
Yeah. Um, discuss briefly about this article on Generalist, where
Hmm.
they brought like discuss what are the trends in AI from the leader voices, and there were a few like things which were relevant to AEC, and we discussed about this collaborative interface briefly in the UI
Oh,
UX,
nice. I
and
haven't read this, but it's nice to be there. Like, okay, I got one.
y- yeah, and then there was one point about digital twins in clinical trials, and
Uh-huh.
there was
Oh,
this
nice.
another interesting thing about chained prompts and multi-step automation, how you could like compose
Chain
multiple
of thing,
large
chain of
language.
thought. Yeah,
And this was like very relevant to AC about industrial automation that solves real world challenge. And
yeah.
then they mentioned
The code.
about this company Argon, where how you can combine supply chain challenges with the construction to like do remote measurement, automated design, coding, extra, etc.
It's always advanced AI. That's the most detail you get. Use advanced AI. Like, what is that? Like the previews you saw, right?
Yeah.
Chain of thought prompting in language models. Okay, I understand what this is about, right? Like, the other one is like, I don't know. But when you get to AC, it's like advanced AI. Like, that's it. Like, there's no like, what is it? But yeah, I mean, all these are really interesting. I guess some of them are more impactful than others from my point of view. Like I like that it starts from elevating human work. I think that's a word I've used like a lot of like, elevate expertise, like bring the human at the core, because everyone is fighting about like all this idea. I won't go into this dichotomy, but people were fighting like, uh, are we are we losing our jobs and stuff like that. So elevate is the point, right? And yeah, the other trends are really nice, like code development is really cool. Obviously, like if you think about code, like, and that's something I'm thinking about now, is that almost all of design can be represented as code. It's not very difficult to think about it as a code, right? As a function and stuff like that. So that's important. Yeah. Uh, there's nice stuff. The interface is obviously, yeah. The digital twin, I'm not sure. Like I know how important it is, right? To have a proper sort of relationship between your model and reality, right? The one thing I have with digital twin is a personal gripe, right? Is that isn't that like modeling? Like we've done it for like decades, right? Like a proper model should reflect reality, right? Something like that. Okay, I understand like maybe the IoT side and the actual real-time communication is what the digital twin is. But I think like, and I've seen a few presentations, I'm not an expert at all at it, but I saw recently here a nice event about digital twins and there were experts there. And like most of them made this point of like, yeah, this is, they started by saying, this is model, like in a way, like reposition it in what it is. It's actually like proper modeling, but then we add on top this real time. But yeah, it's useful if we can make it work. Uh, it's a bit harder with yeah, how do you do privacy and stuff like that. But all these trends seem very nice. I think, yeah, very interesting. The robotics, the final one is of course like the, yeah, industry applications, but mostly there, if you go still, I would bet like 99.9% is like control systems, like, classical control. So in robotics, we have some really cool stuff again with language. So I do think robotics might be a nice, like, fabrication, modular construction, a very nice area. And it's not me that thinks, there's a lot of companies working on it, right? And even there, the interface is becoming language now again, which is really cool. So like, language driven RL and all this stuff. Yeah. So all this seem very impactful. Yeah, a lot of open areas for people.
Yeah, I recall like I think it was a year and a half ago. where like there were a lot of GAN models, and he was like, you said you're more interested in the language
Yeah,
part, and now we're suddenly
yeah, I go one right.
experimenting more. Yeah.
Yeah, it's a conflict. But no, yeah, I mean, the GANs, I mean, if you see also, it's interesting because if you see from the AI domain, most people joke about them. It's like, unfortunate accident that we spend so much time, trying to train them and stuff like that. They were an interesting methodology and still some people use them. But yeah, they had a lot of problems, even though they advanced things incredibly. Yeah, I think diffusion is a huge step. Like as a paradigm, is a huge step. It's going to be applied everywhere, even in language. And yeah, then the language models, they just, yeah, it's all about scaling, right? It's all about the simplest architecture that we can scale. It all goes back to the bitter lesson. I remember I was starting my presentations with a bitter lesson, and I was telling people, this is, if you want to read only one thing about AI to architects, like just read the bitter lesson. It's like 3 paragraphs, and it works. Like, just scale, search, and computation, and it will work. Yeah. So that's what language models did, but they're not the end, right? They're not the end. They have their own problems. Even like a lot of things that are cool things that work right now, I feel they are also evidence of, okay, maybe we're not yet there. Like even the thing that, this prompting works so well, even that is a bit of like, yeah, but there's something wrong with the model if like tricking it with a prompt becomes suddenly better, or so the model should already be something like that. But they are very, very powerful. Yeah, they're very powerful, and they have a lot of room for experimentation. Like for example, this chain of thought that you this multi-chain prompting is really cool. They had a whole trend about chain of thought. It's called chain of thought. So if people want to read about papers, a lot of papers on it. And once again, I will remind, papers are products in AI, and so it's cool because like it's very domain specific, right? It's literally a way to take a model someone made, like a general model, and use your domain expertise to find new capability for that model. It's really cool because you can decompose it. Decomposing a task, that's what chain of thought does. You just do step by step a process. It's really domain. It needs domain expertise, right? So if I ask you how would you build a design, right? You would say, yeah, I start with this, then I do this task, then I add this, you can describe it. And suddenly you have a prompt to give to a model. And if you train that model in this way with these prompts, you see that it learns how to do this stuff, right? I remember with architects, I tried even before chain of thought, I tried the planning thing. It was a very silly example. Like I think I split all my fake designs or whatever in like polygons. So I took a sequence, a random sequence from the network, and then I had the functions say add, like, oh, start the design. Step 2, add a room here. Step 3, add a room. So this was kind of like chain of thought, but it wasn't. So I trained the model in that data. Instead of like the design, I trained on the steps, and it learned how to do it. So already back then I was like, wow, this is crazy because I just gave it like its design was a recipe in a way, right? Of like 15 lines. And then you could prompt it with like, make me this sort of layout, and it would make it step by step. Also, like, that was cool. So yeah, I like it.
I
Nice to
I
understand.
have a like quick question on like, so you linearize the design process to train in sequences, but many times design process is non-linear,
Mm,
where you go back and forth at some point. So how do you codify that part?
yeah. So that's the important. That's where the I think uh, task fine tuning comes into play. Sorry, I would. Uh, I agree with you. Like I think capturing the design is a process, right? And I think when I think about capturing preferences of design, I think about it as across a sequence of interactions. So you need to capture the sequence of interactions, right? And that sequence includes going back and forth, right? So how do you do that? And I think we can codify that and actually deploy it in a model by doing by going into that process and collecting that data. So, like, actually imagine an interface with a designer and sort of collecting that design process from the beginning to the end, and then using those steps. fine tune a model, right? That's exactly what instruction tuning is, right? All these models, and I think that's what we need. So, for example, in the interface we're making, that's how I imagine it. Like you would have like multiple branches. Let's say, make me a layout like this. Okay, do you like this layout? You give it a ranking. You type a natural description, maybe a critique. I think these bedrooms on the west side are too small. Okay. Then you ask them, okay, what edit do you want to do? Maybe delete these bedrooms, and make me another one. You generate. Do you like this one? You score it again. Yeah, the bedrooms are now better, but this has an issue. Then maybe you can interrupt this process by showing them, was this better or the previous? Okay, you store that data. So you have all these interactions. You need this sort of multiple branches and interactions, and you need to collect that data, right? And at the end, you can use that sequence of interactions to train the model to do various things. Yeah, that's how we codify it. So you actually need to collect it, and that's what I was saying before. We already do this, right? A designer, like you say, they already do this design in steps. It's just that the in between steps are never saved, right? That's the problem. We never save like the artifacts. So in a way, you need to constantly save these snapshots and then use them as a sequence. Yeah.
Yeah, so one way to do it would be like I just had a thought. What if there is a competition where there's a task, draw a particular floor plan, and we make a log of how 100 designers do that task. And a basic way to would be doing is every time you do a function in Rhino, you capture and append all the sequences, and then we could do like a correlation of all the steps in that sequence among all 100 designer, and then we could generalize a bit how most of the designer approach a particular problem.
Yeah. Yeah, exactly. And even if you don't generalize, you can create personas again. But yeah,
Yeah,
but that's the idea. Yeah, that's the you need to, and there are two difficulties there. Like first, people have done this for decades, like in the evolutionary design area, and it doesn't scale. Like they always talk about fatigue and like people just blank spacing out. They don't want to do this, uh, so it has to be like somehow in workflow and without interrupting them. Right? It has the software itself needs to store all these things, right? And this is something that code does very well, right? There are like every time you pull or you push on GitHub or whatever, you have this history of diffs, right? So you need these diffs. That's how they call it, and that's how. So essentially, what we need first is to collect a data set of these diffs, design diffs, and then train a model that can do a differentiation, right? That's the first step. Because again, even if you collect this data, collecting this data is how you train this model, but the collection of this data doesn't scale. Even though we need it, we cannot do it forever. So the whole point of this approach is to do it once or twice or per task. And once you do that, you train another model that kind of does it for you. And then if you want, when you deploy that model, you can take, people can rank it, reward it, say this is good or not. You can fine tune, right? But it doesn't scale. But yeah, you need to collect this data, and it has to be in workflow. And yeah, like I said, like we already do it. Like I think I have like some tasks. I made like a framework. I remember like writing down this task, and it's when I look at it, it's really things we already do and like actually do in stages of projects. Like I have design generation. Okay, so you have a prompt or a question and you generate a design. Okay, we do this already. Design review. We literally have design review reports, right, in our projects. What is design review? I have this input and output, and then I review. Is it consistent, right? Is the input output? And this is exactly why you're doing the reviews. Is this design consistent to the requirements of the project or whatever? Then you have an evaluation, right? So once you go through the review, you have a critique. Okay, here there is an issue. This is an issue. I highlight an issue. Then you have a refinement. Okay, based on an input and an output and an evaluation and requirements, this is what you should change, right? So we already do all this stuff. And this is what we just need to find a way to store sort of the artifacts of each of these steps. And then you can have either initially a model for each of these. So you can imagine a model that you give it an input and an output, and it creates a critique for you. That's quite useful because you can then, I don't know, pass 1,000 designs through this model, and you will create 1,000 critiques in 1 minute. And then you can spend your time fixing those critiques, right? They're a starting point. Or this doesn't need to be design at all. You can be a very large document of 150 pages, and it will create small critiques for each of the passage. And that critique, for example, might be, oh, this passage needs to be read by this person, right? So that's what I mean by expanding the scope. This is still design because the requirement has to be read by a person in the project, but linking those two is hard in 200-page reports, like how we do it by reading them, right? So like you have these models one by one, and then you compose them all together in new types of processes in a way. At the beginning, in the future maybe it's one, but the beginning I think has to be one by one. Yeah, there's a lot of
Yeah.
cool stuff.
Yeah. I wonder, like, the Bluebeam report, like Bluebeam is a software where a lot of times we go back and forth. Okay, fix this, have all the callouts, and then do the feedback. That could be extracted out. And
Yeah,
the challenge there is with those drawings, we don't have the segmentation.
yeah.
So,
I mean, the minute things become PDF, it's gone. Like it's done. Like, I don't know. I think a big step towards AI in the AEC will be when we stop using PDFs, or at least when we store the file before it became PDF, and we have it somewhere easily accessible. Right? They're just like it's a huge bottleneck. But yeah, for designs, I mean, they are images anyways. You still exactly you need to save that data somehow. So for example, imagine how many people are doing daily these callouts, right? How many people go in AutoCAD, in Revit, in Rhino, wherever they do it, in ArchiCAD, and they sit over a design and they make callouts, right? So what if you have a process that while you were doing that, you would save very specifically, what the input was, what the review was, what the callout, what item was highlighted, for what reason, and then when the person who gives the response, that gets saved to the sequence. Oh, the other party responded this to this callout, and you need the structured data. And if you have the structured data, then you can easily train a model that helps you do that, right? The review. And yeah, that's part of the data we need to generate. We don't do it anymore. We don't do it yet. We do it daily, but we don't save it, right? We really don't save it. So and you can do that. We can make an interface. That's the whole idea. I think you need to ask people to sort of annotate for you. Yeah, there's a lot of, but it's totally doable and it's really powerful. And one of the power of these techniques, that's why I think the AI domain has shifted to them. This instruction tuning is that they require a few orders of magnitude less data. So like if you want to pre-train a model, like Stable Diffusion had like, I don't know, 2 billion images. And that's why exactly people now, I see a lot of architects in Midjourney, creating, oh, look how nice are the sections I created, right? It took a few hours of work and a few creative prompts, right? It's not so easy, but I can do these amazing drawings. Yes, of course, because it's in like 2 billion sample points. In there, there's a lot of design points and also another rich latent space that you can attach to, right? But we don't have 2 billion data sets for projects, right? Even if all, I have said it before, even if all the AC comes together, our data sets are laughably small, right? Even if we could share them, which we cannot. So instruction tuning, all this fine tuning on a specific task with expert knowledge allows you to do it with a few hundred or a few thousand samples, right? You just need to make the effort in a way. And that's what I'm most excited right now about my work. This is, I think, uh, yeah, we're focusing on that, and I think it's going to be a big thing in the future. Yeah, near future. When I say future,
yeah, to your point, like we lose information in PDF. But I think like PDF is the most common mode of information exchange among various parties in a construction project.
yeah,
So, like,
it's a problem. Like that's why it's still $1 billion industry. Like the person who can manage the PDF to structure output, they will be $1 billion company the next day. There are like solutions out there, paid, open source, but they're not. Everyone who uses them, they're not perfect, right? And the problem is, if you want to do it like at scale, let's say you have 10,000 PDFs. Okay, I will use like open source project PDF to text. Okay, it's a Python library. Oh, it's nice. It comes out. It's kind of okay, but then you see it's not really okay. Like the line breaks are not nice, the sections maybe are lost, so it's gone. And then there's so much noise in there that it's not useful anymore. And if you use a cloud service, maybe you have to pay, you don't have the money, but still it's not perfect, right? How do you export images from PDFs or like tables? Is it perfect? It's just not ideal. While, even Word, which is again not the perfect, but it's okay. Even Word is like an XML. I can query, right? I can say, give me a section, like give me the document, give me. So it's better. We need these structure inputs. And PDF, people forget that they are images, they're not text. Like we use them because maybe they look nice or they easy, or we don't want people to copy paste things easy. I don't know. Like it's, but yeah, if we are serious about using this form of modality, we need also other inputs. Uh, yeah,
Yeah,
but yeah,
maybe if there's like a web-based like Bluebeam, where in what while defining the function itself, where okay, callout, that structured output is saved in the database with
yeah,
logs and with that is smart way of capturing.
yeah. I wish we could write all our reports in Markdown or something. Perfect. It's like a common format for everything, and then you can parse it very easily. Something like that. Yeah. But yeah, I mean, it's okay. You need to do the work. Like it's not that you cannot do the work, but it's just that, like I said in the beginning, right? It's not that I personally cannot like grab all the PDFs, export them, and maybe slowly, painfully process. Okay, everyone can do that, right? Ideally, you don't want to do that because it's a low. While you do it, is a low value job. If you finish it, it's an incredible value. But while you do it, it's hard to explain to others. Like I want to spend like 5 hours a day fixing documents, right? They will say no. So it's not that we cannot do it, but like I said at the beginning, is that we need to implement processes that are different than what we were doing before. So it's not about, oh, I can do this processing. It's about, okay, it's okay. We have an issue. All our previous documents are PDFs. Okay, no problem. Can we start today and create data that is structured and I can access and I can process easily? So that would be a huge step already. Even if you get no support for processing your previous data, if you started today to create them in a different format, then in a year you would have a lot of data to already train things, right? Like that's the idea. Yeah,
But
that's the
the
information.
challenge there is what structured data should look like. The small firms or the big firms who wants to do AI, but we are also not providing templates. Okay, we made a plugin in Grasshopper or Autodesk. You just integrate. Now you're getting structured data. So I
Yeah,
think we are kind of missing the pipeline or templates
yeah,
to capture that.
yeah, definitely. Yeah, it needs a whole data strategy. Like a whole strategy. It's like big organization. I'm sure have it. Like I know for a fact. Like it's very important. So it's not I'm the first one
Yeah.
who thought of this, right? People have been thinking for decades. It's just like, yeah, I mean, in the day to day to sort of do it, right? Even this practice of like, okay, let me export in PDF and send it. That's okay because you need to communicate like that. It's easy to open a PDF. I can see it as an image, right? I don't need like software to pay or whatever. But at the same point, you need either yourself or an automated system to say, okay, this PDF was created by this report. I store it in the database. You can retrieve it anytime you want, right? And you keep the original. Anyways, I'm going. This is just a minor issue of processing, but it hits on that point of like creating the processes. But you're right, yeah. We need to sort of implement those processes. Like in design, we don't have that much problem. Like in computational design, at least that I used to do mostly, everything is sort of structured, right? Like so, it all is like arrays and data and tables, and so it's not a big problem, I think. But yeah, in the language modality, it can become a problem. And you saw like in Galactica, the latest model, the one that has a bit of noise lately. If you read the paper, that's what they did. They created I think, a small relatively data set, 100 billion tokens, something like that, but they're all the same format. So it's not like different sources extract PDFs and process with scripts. They're all the same markdown, and they curated it extremely well. Like they a lot of effort in being clean and everything. I'm not sure if they can share it. Maybe not. Uh, but that was the important thing, right? All a common format, and then you can use that to create many different things. That's what we need to find, a common format in a way, for the different modalities.
Hmm. So I have used Luma AI recently,
Hmm.
and it could capture like total 100 frames in all different plane, and then you can generate like a instantaneous, like not instant, they do cloud training, and within a short period of time, in a minute or two, you get a 3D model output in obj as well as a video. And they are using nerf, and we are seeing a lot of like generative AI models from multimodal. I'm wondering, like, where are you seeing like the generative AI industry towards like nerf based generation
Yeah.
or VAE based, or yeah.
I think we're very close. Like I think it will have a huge impact in certain areas. I think obviously the first area you can think of is what you mentioned with Luma AI is assets. So like 3D assets. So I think very soon we will sort of even already popularize this, creating 3D assets very easily, right? Uh, that's not necessarily revolutionary in the sense that, a lot of games have assets already, like 3D scanned and high quality, right, that are open source. But the revolutionary part is that everyone with a phone can do it. So you can create your own assets for your own game. So, and I'm not sure how long it will take to have like a generative model for assets. So the Luma AI, I imagine it's something like NGP. I don't know what they're using, like a quick nerf process, right? Which is amazing actually. It's brilliant. Like it's also an amazing method, but it's not like generative. It's not conditional, right? It's not like or actually unconditional either. It's not something you can say. It's not an implicit representation. So it's explicit, right? It takes like it scans this area and it creates, I don't know, this statue, right? The 3D. So you can't really prompt it, give me another statue. You can like play with the latent space to it. So that step will happen. I think once these services are popularized and we have again billions of 3D assets, right? And then we can train a model over billions of 3D assets. So we are close to that. I've always been not negative, but I've always focused on the 2D side, on the architect stuff, because I thought, okay, there's not a problem. Like in our domain, it's very easy to go from 2D to 3D. It's natural. Maybe for other people, it's harder. Like they've never opened a design software, right? How do I create a 3D model? I can just scan it. It's nice. But for us, maybe, a 3D building is just an extrusion of a 2D layout, right? But I do think we are getting there. So I'm not, I have changed my position quite a bit because we're much closer. Uh, I, but yeah, I don't know when it will become useful in the sense useful, right? Actually generating something that you put in a project or in a model, but that would be probably very close. I would put it in maybe 1 to 2 years, right? So it's closer than I thought. And but yeah, the assets will be the biggest part. I think like gaming industry probably will have a lot of impact. They will have a lot of impact there, if not in like AAA games, which already again have a lot of assets and people working in like making a game yourself, that kind of thing. I think that's where the initial techniques, that's what they popularize. I think they democratize access. That was the whole idea of architects as well. Like anyone can type a word and make a design, right? So I think they will democratize access to these harder things, like how do I make a 3D asset? I don't even know. Let me use my camera. uh, but to become like industry staples, I think they will need the whole process that the other models went through, like $1 billion samples, training, and then we have a generative model for assets, and then we improve on it, and finally we have a production ready tool like Stable Diffusion. I think is
Mhm. Yeah, I think you got a really good point about of that explicit representation. I I don't have the control over latent space, and that's one of the thing, coming back to the UI UX, where when we are using DALL-E stable diffusion, we don't get the sliders as we good used to get in GAN, where I can morph it in a particular direction.
yeah.
Obviously, I could play with the words in a particular semantic slider and modify it, but we might need some different discretized text multimodal approach.
or a different interface. Like what you're describing again, I think is that the interface changed. Like StyleGAN, for example, yeah, it has a sort of structured latent space. That's why you could like sort of
Mm,
interpolate through it. You can still interpolate this stable diffusion, but between prompts, between
yeah,
places of the
yeah,
design space. So the design space is much more complex now. That's why, like, it has like not just faces where you interpolate from woman to man or something like that, old to young, but also like from concept to concept. But yeah, I think it's just a different interface, right? Like, again, I'm okay if and a bit touching to computational design a bit, I'm okay if we replace sliders with language. That would be nice, right? That's one good step. So we have no sliders, nothing, perfect. Even if we can replace wires, even better, right? Because all of it at the end of the day is some sort of logic you're describing, right? And if you can generate that logic semantically, then all the better, right? And because again, everyone can then use it, right? Just imagine an interface like Grasshopper, for example, for people here that might be architects, right? Computation designers, or Revit, or Dynamo. But imagine that, I don't know, anyone could use it. That would be amazing, right? Because the things that we do with Grasshopper, like if you go on YouTube, right, the first things that pop up when I learned back then, it was like, make a twisty tower, right? That's the first,
yes,
like, okay, let me see, how do you do it? And because I wanted to know and I was in the industry, whatever, I could do it. Like I had the software access, I kind of knew my way around it back then. So I could follow along and learn how to do a twisty tower. But imagine if the person doesn't have the time or willingness to do that, but they can still make a twisted tower. How? By simply interacting with that interface with language, right? That would be amazing. And then underneath the same logic happens, maybe the same parametric model is created. So I think that's a great future in a way. And if you go, and it's not only about democratizing outside, it's only inside. Because again, think about the big organizations people might be in. How many people use computation design? Like even in an architecture firm, what's the percentage? I would imagine right now we are at the biggest, at the peak, right, of computational design, like dissemination, right? It's still like, is it 10%? I don't know. Is it 20? I don't know. Like, I don't know. Like actually knowing, like I can take a description, I can create a script for you. So there's still a bottleneck even with experts. So yeah, it's be nice to do that, new interfaces, and that's what you said. Like language will be this new interface, I think. Uh, Everything, yeah, just yeah, easier, and it's more accessible and everything.
yeah. Like I wondered, like we as like we might need a modular interface in the software or the website we use, where depending on new state of the art model, we just replace there's a drop down, select the model, and you just replace it, rather than like, because things are moving very fast, and one would like, okay, I want to do generation with the latest model. So how do you like architect in such a way that in Rhino, every time I open, I can just check out latest model and do generation? Oh, I
You
lost
are
you.
muted, yeah, 2022 again. I'm not sure. That's the part where has anyone succeeded? How many companies failed there in AC? Like the collaboration part, like how we bring it together. Like there are different strategies, I guess. Some parties, their strategy is like you can collaborate because you can do everything on our platform, right? That's one strategy. It's easy to collaborate because you never need to exit. Others are like let us be the node between things, right? But again, I think the complexity there arises. Okay, obviously it's a very complex process. Like different people want to do different things on different parts of the design, different aspects. They have different requirements, understanding all this stuff. Which again, and the other is that all this software have different formats and different, so nothing works together in a way. So it's very hard to collaborate. And the things that we see coming out, there are some hopeful. Like you can see, like I don't know, Nvidia's approach, like perhaps like the most hopeful thing will be the USD and all the again common format, right? Open source, hopefully not closed source, but it's still like it reminds me a bit of the XKCD stuff. Like, okay, we have too many, too many formats already. What do we do? Let's make a new one. Like let's make a new format that encompasses everything. And it, at, so at the end of the day, at some point, I think maybe that format we already have it. Again, I'll go back to language. Sorry, you want to say something?
Okay,
Is it?
I think
Yeah.
it's working now. Yeah.
Oh, okay. So at the end, maybe this format we already have it. I think again, these models might become the new interface of collaboration between this thing, either by abstracting some of the complexity of formats underneath them for a time, not completely, because at some point you also need structured outputs. You need like some sort of, I don't know, something like IFC, I guess. It doesn't need to be IFC, but you need something detailed, all the elements, so you can construct it or whatever. But for some steps, I think you can abstract it through these models. And again, hopefully the interface we discussed. Like, so I expect that you will need an interface that can adapt in that way in order to truly collaborate in our domain. And yeah, I don't think that can exist somewhere within, disparate software that don't talk to each other or barely talk to each other, this kind of thing. The other issue that happens is that this is counterintuitive. If you really want to go towards the AI driven side and sort of like drive a lot of the parts of overall design, not just designing and the whole process, right? With AI, then but some of the software or all of them right now are bottlenecks, right? They are not built to work at the scale and speed of the AI models. They simply are not, right? I can inference a model, with batches, in milliseconds, right? You can't do that. So one thing to consider is like how we chain this together, because in the beginning we will have to chain models and software, and we need to be aware that software will be absolutely the bottleneck there. Simply it cannot keep up, right? For example, when I first made some models, I was thinking, nice, I can deploy this in Grasshopper, right? It's cool. And I did. And I remember one of the first models I made, I took the dataset, this open source, of the thermal comfort of the UTCI. So there's an open source UTCI dataset. It's actually a table lookup. That's how they do it. They have all the temperatures and all that stuff. And I trained a regression. I trained a GBM. I remember a gradient boosting. And the reason I did is like, why do the calculation if I can inference? It was indeed faster. So I could give it like some inputs, temperature, humidity, whatever. It would be very good. And then I deployed in Grasshopper. I was like, this is much faster. And then I realized that it's really fast. They even deployed it there, but all the rest of my canvas is very slow. So what's the point?
Mm.
And this becomes worse if you do like architect stuff or like language model stuff or like. So yeah, that's one thing to consider when we are composing these workflows. That yeah, the bottlenecks will be there. You can alleviate that by you don't always need to run through a design, right? You can alleviate that by, I think that's what my idea is so far, to use those softwares as places of reflection in a way. So if that makes sense, like if you have something like architects, you don't need to generate anything in Grasshopper, for example. You can generate it with your language model, right? Or with your generative model. And then your Grasshopper like interface or your Rhino or your design software could be the place you reflect. Perhaps you visualize data, you extract some insights, you test, you sort of, you visualize a bit better. So that's my take so far of like how to compose models and software. Software becomes just a place where, but slowly even that you start thinking maybe I can do this on the web. Anyways, but yeah,
Right.
that's my take on the software side and collaboration. It's hard and it becomes easier with models, but then when you have mixed compositions, then it's something to think about how
That's a great insight. I'm gonna wrap up with a rapid fire, but before that, I thought if you know someone, or like I will also look it in my circle, it would be great to organize a workshop for making ML interfaces or UI UX workshop, because I think it would be really useful to a lot of AI AEC tech people.
yeah. I'd love to be there and learn because myself I'm not very good at UI UX. Yeah, but that's why you need a room. So yeah, let's make a room.
Yeah. Okay. So coming to rapid fire,
Mm.
what are three to read ML papers in your bucket list now? Top three.
Uh, Top three. So I think all of them are from instruction tuning. So I can actually say the title so that we are more clear. So I would say the Anthropics paper about the Anthropics paper about instruction tuning and making them honest and non-harmful and all these things. I think the the Google Flan paper was quite interesting, and I'm sure I can remember the titles, but the titles sometimes they don't correlate with this models. And and I think like like preference learning and like fine tuning to find agreements between humans and preferences. That was good. Like they're all about instruction tuning. That's what I'm reading now. And the Galactica paper was actually good. It had some nice this discussion of interfaces. We're discussing some elements there to read for non AI people. So yeah, I think though that's what I'm reading right now. Yeah.
Awesome. And any insightful or thought-provoking podcasts you heard recently?
Yeah, I mean, there are a few. I did listen to the ML Street Talk, as I said, with Aiden Gomez. That was nice. Uh, then I spend most of my time in text-based communication, so Discord. I recommend people to join Discord communities.
Which
There's
one
quite a
do you
few.
particular?
I'm mostly in Eleuthor AI, but there is a lot of them. There is like stability type. I said there is like Carper AI if you want structure tuning, human feedback. You can go to Lion community if you want all this multimodal image-based stuff. Uh, a lot of companies like Cohere for AI is very nice community, supportive, and the cool thing about it is that they also I've seen that they create projects. You can volunteer, you can learn. There is a lot of like nice opportunity if you have the time and passion for it. Yeah, so I will definitely join a Discord community for sure.
Cool. And anything like paper or video you saw which like stood out?
Yeah, I mean the paper I really like. Yeah, a couple of days ago, the Instruct Pix to Pix. I liked it for two reasons. First of all, it sort of brought back Pix to Pix, which is one of my favorite models. Is a model that is somehow forgotten because no one cares about this task of like, oh, I take an image and I keep it in the same domain and I just edit it. But it shows the potential of like what I said, instruction tuning uh, on the visual domain and how this instruction tuning of like explain with instructions what you want to happen is applicable almost universally. Like you can do any task with this approach, right? So the instruct pix to pix was nice. And videos, I think I saw a video that I like. Again, it's all about this. I think it was Ethan Perez, and he was talking about their paper like learning with human feedback with OpenAI, and it's a very nice video because it goes through the framework and describes how it happens. And I can find the name. I can't remember it now, but I can find if you search those two words
Hmm.
like Ethan Perez, you will find it. It's quite nice. And it goes through also the alignment side of things because it's not about having models that can do things. It's also like having models that do things correctly because you don't want them to be misaligned to your objectives, right? Or to what you're asking them to do. And the problem there is not that they will do something very obvious and then you will say, oh, this model is very bad. Let me fix this. Is that they will be misaligned in a very exploitative way. They will create non-obvious mistakes, right? Sometimes by gaming the reward function. So there's a whole domain of alignment that is extremely important. And another domain that I think we can offer a lot in terms of use cases, experiments, and experiment environments to test alignment. But that video goes through also that how this whole human feedback approach could help with alleviating this, right? And there are some interesting ways how this happens without us knowing. The cool example they mentioned in the video is the recommendation system. So people have found that in large recommendation systems like Amazon, In fact, the model itself is manipulating users to improve its performance. So it's not showing the user what the user might want to see. It's showing the items that make the model performance go higher. It's a very interesting, and this is actually a real phenomenon in the real world because it's also manipulating buying. The user will follow this recommendation eventually, right? It's like subtle differences. And imagine what happens if this happens in design. So imagine you have a very powerful generative model that instead of showing you know, cool designs that you might want to see based on your inputs and requirements, it's showing you designs that just improve that reward function of you that whatever you have, like, and but marginally push you where you don't want to go. So yeah, that was an interesting one. I will find the title to show you.
That's awesome. Any upcoming AI conference or events you are looking forward to?
Yep, Nurips. I registered in Nurips. I sent you the video by the way just now. You can share later. I just registered for Nurips. It's actually a bit more expensive this year, but still quite cheap. So if you're a student, I think it's $100. It used to be 80, and that's crazy because if you think of like AEC conferences, I think they are three times the price. And this is Nurips. This is like literally the biggest conference in the world. So definitely, like, if you are interested, you have some time, you're in the right time zone. I'm not. Uh, just register. There's like, if you don't want to register, no worries. Even here's another area where AI's conferences are better than ours. A month or two later, everything is open source. So just go to the site, and you can watch all the presentations, all the discussions, yeah, it's really cool. So that's the one I'm expecting now. It's happening anytime now, I think.
Yeah, so the in-person is last week of November and the
Yeah,
virtual one is first week of December. Actually, I'm
yeah,
looking forward to the creative AI workshop. There are
yeah,
some
yeah. I
really
think
interesting.
it's second or third time they do it. Yeah, okay, maybe a few times. I don't know if it's the same as the one I used to watch with Ha, but yeah, it's nice. I wanted to put architects there a couple of years ago, but I never did. But it has a cool stuff there, cool work.
Awesome. Is there anything else which we didn't cover in this interview and you'd like to share on an ending note?
No, I think like the ending is always the same. Like, just try to keep up. Like, if you're interested, like, don't be afraid to sort of dive into this. Like I said, like, it's not about reading and understanding every single detail of what comes out. It's about getting intuition. And because of how this model is becoming more mature and deployment more mature, and how the interface changes between them, I think it's getting easier and easier for architects, engineers, designers, anyone in the AC to get involved. Because the same way they are changing the interface to other things, the interface to them is also changed, right? For example, we discussed how prompting has now become a huge part of research and applications. So, and prompting is literally, deploying domain expertise. So, like, my last bit would be like, don't be afraid to like experiment, dive into it. Like, there's nothing to lose, like, and very much to gain, I think.
Awesome.
Yeah.
Thanks a lot for your time and look forward what you're building.
Thank you for having me. Thank you.